Okay, we're going to look at aromatic rings with nitrogens and oxygens in them. You can have the other elements that are below them in the periodic table in the aromatic rings also, and they do exactly the same things as nitrogen or oxygen. So sulfur does the same thing as oxygen, and phosphorus would do the same thing as nitrogen. So what does carbon do in an aromatic ring? Well, carbon does the same thing in an aromatic ring that it does in a double bond. It's sp2, so it has 3 sp orbitals that are at 120 degree angles. These hold 1 electron each, which allows them to make 3 single bonds. There's a leftover p right here with 1 electron in it, and this can participate either in a single pi bond, or if it's in a ring, or even if it's not in a ring, if it's an open chain with lots of other p orbitals, you can participate in a many orbital pi system. For every p orbital that you have, you're going to have 1 molecular orbital. What can nitrogen do? Well, nitrogen in a double bond, which it can be in a double bond, if it's in a double bond, it's going to be sp2. And it doesn't matter if this double bond is isolated or if it's in an aromatic ring. It's going to be sp2. Well, if it's sp2, then you have 3 sp2 orbitals at 120 degree angles. And what do you have? 1 orbital here, 1 orbital here, and 1 orbital here. And one of these orbitals is holding 2 electrons as a non-bonding pair. The other 2 are just forming sigma bonds. There's a leftover p here also that has 1 electron, and what is it doing? It's participating in either a single bond or a many orbital pi system. So anytime you see a double bond to a nitrogen, the non-bonding pair is in an sp2 orbital. Anytime you see a double bond to a nitrogen, it has 1 electron in a pi system. What else can nitrogen do? Nitrogen can also have 3 single bonds to it. Now, normally we think of nitrogen with 3 single bonds and a non-bonding pair as being sp3 hybridized. But if there's a pi system adjacent to it, the pi system induces it to become sp2, and it hogs a single p orbital. So, if nitrogen is sp2 hybridized in this circumstance, what happens? There are 3 sp3 orbitals at 120 degree angles, and each one of them is holding 1 electron that allows them to make 3 single bonds. But the non-bonding pair is where? In a p orbital that is in the pi system. What can oxygen do? Oxygen normally is, when it has 2 single bonds to it, is sp3 hybridized, and the 2 non-bonding pairs are in sp3 orbitals. But again, when it's adjacent to a double bond, it induces it into sp2 hybridization. That sp2 hybridization gives it 3 orbitals that are sp2. 2 of them are used to form the single bond, and 1 holds a non-bonding pair with 2 electrons. The leftover p has 2 electrons in it, and that would have been a non-bonding pair if it was sp3 hybridized, but because the pi system is nearby, it now is a bonding pair. It actually cooperates with the pi system and participates in it and donates 2 electrons. And all these atoms do these things whether or not it's an aromatic ring or an anti-aromatic ring. So really, you just use the rules. What are the rules? So use this. An atom with a double bond is giving 1 electron to the pi system through an unhybridized p. And an atom with no double bond but has a non-bonding pair is giving 2 electrons to the pi system through an unhybridized P. The next thing that confuses students is this. To get charge, you have the homolytic breaking of a bond. So what happens? Either the electrons move to one atom or to the other. So it's a pair of electrons are leaving the bond and going onto an atom. So if the electrons end up on hydrogen, what do you have? A carbocation and a hydride's taken away. The carbocation is sp2 hybridized with an empty P. We went over that last semester. What if the electrons end up on the carbon? Then you have a carbanion and a proton is taken away. That carbanion has those 2 electrons in an orbital, and they can be that orbital can be 2 things. If there's no adjacent pi, what happens is the pair is in an sp3 hybrid. But if there is an adjacent pi system, the pair is induced to a p orbital that's in conjugation with the pi system. And so when you see a positive charge in a ring, and on an atom in a ring, there's no electrons from it, just the empty p orbital. When you see an atom with a negative charge on it in the ring, it's providing 2 electrons in that pi system. So it's relatively easy to think about that. Just realize sometimes the non-bonding pair on the carbanion is not written. You have to remember that negative charge means 2 electrons. So now, knowing what you know, how many pi electrons are in imidazole? Well, if we go to count these, you know that this nitrogen has only 1 electron in the pi system because these are in an sp2 orbital. So 1, 2, 3, 4, and then the nitrogen has what? 5, 6. This is an aromatic ring. Okay, how many pi electrons are there in thiazole? Realize the non-bonding pairs are there, they're just not shown. Well, to go and do this, first thing I would see is that the sulfur must have 2 non-bonding pairs. And because there are double bonds on either side, one of them must be in the pi system. So 2 electrons from sulfur. And if I look at the other atoms, they're all in the ring. They're all in a pi bond, or written as in a double bond. So I know each of those are giving 1 electron, including the nitrogen is only giving 1 electron. Each carbon is giving 1 electron each. So 3 electrons from the carbons, 2 from the sulfur, and nitrogen gives 1. So the total is 6, and that's an aromatic compound. So now you tell me, what hybrid orbital is on the non-bonding pair in nitrogen in? It is sp2. Why? Because 1, 2, this has to be sp2 hybridized in order to be in the pi system. 1, 2 those are 2 of the sp2 hybrid orbitals. Right here, this bond is formed by the p orbital. So that must mean there's an sp2 orbital stuck out here with 2 electrons in it.